Okay, here's a question about modulus graphs. You'll notice that inside every modulus they're just linear functions, which means that all of these are going to be the familiar V-shaped graphs. And a dot e1 is one of the easiest marks you'll ever see. A dot e2 is quite tricky for 2 marks, and it leads in to part B. You'll see that this graph here is going to be relevant to that and to this. This kind of graph sketching is the trickiest one. If you're thinking the point of the V may have an x-coordinate of 4, then you need to think again. There's more than one approach to this. Your teacher will have shown you the one that they want you to use. It's actually, the example to look at for that is example 6a. Will involve not only that kind of graph, but also using it in an inequality. So if you look at that example, hopefully you've got a clear description of the method you need to sketch that kind of V. Now b dot e1, even if you couldn't do that, solving an equation you can actually do without reference to graphs if you're careful. You need to think about the possible things that the modulus function can do. One of them is to leave the expression inside it alone, but the other is to adapt it in a particular way. So this could be 2 possibilities, this could be 2 possibilities. In principle you could end up with 4 different equations, okay, depending on whether each modulus sign leaves the thing unchanged that's inside it, or makes the change that it could make. But you'll discover if you do list all 4 of these equations that there are only 2 fundamentally different ones. And if you solve those 2 equations, you'll get 2 values of x, which will be the answers that you need to that equation. And you don't actually need to refer to graphs. However, if you do that using graphs, as you may have been shown to in your booklet, that will help with this one, because for the last one you've got 2 V-shaped graphs, and we're asked for the x's where this graph lies above the other one. So you've now found the intersection points of the graph. Your sketches, which should have been on the same set of axes in part A, should enable you to pick out the bit where that graph is above that one, and so you can say what kind of x's are good in relation to the critical values where the 2 graphs, from here, the 2 graphs equal each other. So good luck with that one.